Here's an IC25A 2-meter FM transceiver. Recent hamfest. Of course I asked, did it work? He wasn't sure, so I'm sure this will be a repair. It's got a neat old microphone though, came with it. Original Icom mic. Kind of nice. Don't know anything about it. Hooked it up to power. I'm going to power it on and see what we get. Ooh, didn't like that. Seeing the squelch doesn't seem to be working. It's offset. Whoa. That's weird. Wow. Okay, if I hit simplex, squelch doesn't work. If I hit simplex, now I'll key it. Ooh, that didn't sound good at all. So obviously it's got a problem. Audio amp's working. Hold for low. It's still no output. Now we're not getting. Now we're not getting any output. Now before, yeah, we got an intermittent. Okay, I'm gonna pull the lid off here, and obviously it's got a problem. So I'll pull the lid off. We'll see if we can find out what's wrong with this thing. Stand by. Well, I got the lid off, and here's the symptoms. Of course, the squelch is not working, and it is receiving. Test 1 2, test 1 2 3, test 1 2 3. So that's working, and it is transmitting in low power, very low power. Test 1. Test 1 2 3. Whoop. Test 1 2 3. Test 1 2 3. Test. Hello, test 1 2 3. But when I go to high power, nothing. It is measuring higher power, but it's doesn't sound good. So I'm not gonna do that too much. So I guess the first thing I'll try to get the squelch working, and then we'll figure out why that transmitter's going haywire there. Could have been golden screwdrivered. I don't know. Hard to say. Test 1 2 3. Test. Test 1 2 3. 1 2 test 1 2 test 1 2 test. Hello test 1 2 3 test. Okay, anyway, we're going to have to dig into the schematic and see if we can figure this out. So that will be the next steps. This is the circuit of the main board on the unit, which is right here. And I'm measuring on pin J1. This is a squelch terminal. And if you look on here, here's J1, it says squelch. And if you follow that over here, Q19, squelch off at 6.3 volts, on at 0. So now I'm going to vary the squelch pot, and you'll see the squelch is stuck at 6.4 volts. There's no variation, so we've got a problem here. So it looks like I'm going to measure, I'm going to go work from this point back. The way this works is noise coming in when there's no signal comes in and it's amplified. These two transistors rectified, and it develops a voltage here, and it looks to me like they turn this transistor on, and that'll take this point to ground, which turns the squelch on. And we got a problem, either Q19 or someplace ahead of this, but I got to make sure I'm getting my noise signal coming in through this cap into here. So I'm going to do that next. And the supply voltages look good. I already measured those, so that's not the problem. After the discriminator here, the squelch circuit, it taps off at this point here. You can see here, right before de-emphasis network, low pass filter here. Anyway, it's tapped off here. The noise is sent out through this line, which I've colored in blue. It goes out to the squelch control. It says squelch 3. It goes through that pot and comes back through squelch 2, and it's connected to Q17 through C121. So when there's no signal, there's a high level of noise at this point that's fed into here, and then that noise is amplified, and that level is set by the squelch control. Now I've got the scope connected up to squelch 2, this pin right here on J8. So I'm going to measure the amount of noise that's coming in on that signal. If you look at the scope here, I got the squelch control I'm going to vary. Okay, I'm going to turn the squelch control, and you can see the noise coming up. So the noise level is coming in. I'll turn it back down. That's the noise that is amplified and then detected to operate your squelch. So we know we have signal here. So now the trouble has got to be in here somewhere, because ultimately here's the squelch switch Q19, which will silence the audio here. When there's no signal, it'll cut it off so there's no noise. So we need to look further and find out where we have a problem here. Here's where that noise is amplified by these two transistors, and then it's detected or converted to DC here, and it develops a positive voltage across this cap here. And since this is an NPN transistor, the more this point goes positive, the more this transistor turns on. So here you can see it says the squelch off at 6.3 volts and it's on at 0. And right now, as I showed earlier and tested, this point is stuck at a little over 6 volts. So we're going to investigate this circuit next. You know, it never fails. I want to measure the signal at the base of Q18, okay? And I got a resistor here, base resistor, part of a divider here for bias. Anyway, I'd like to measure this point here. Well, these resistors are mounted vertically. So guess which side of the resistor is down? Yeah, you guessed it, it's this side. The ground is the one that's sticking up. That's this resistor right here. So this point here is the ground side, and the one I want to measure is on the board. Why they didn't flip that around, I don't know. Just makes it more difficult for people that want to work on it. You know, I have a feeling I got some electrolytics scattered in here. I don't like shotgun troubleshooting, but I bet you if I replace some of these caps here, I mean, if you look in here, here's a base or a emitter bypass cap here, and you got these. Here's an electrolytic here and here. I bet you when I get done, I'll find out that those caps are probably bad. But we'll keep trudging along. Well, moving right along. Couldn't get access to this, but this resistor R106 that feeds the base of Q18, I was able to scrape off the paint on one end of it, which is right there, and I am getting the noise, which you can see is varying with the squelch control. So we're good. up to the basic Q18. Now I need to work my way on the output of there and make sure there's some gain. It does have a voltage reading here of 4.0 on the schematic here. I can check that also, although getting access to these is pretty tough. The leads are buried here and they're so close together. It'd be nice to have access to the bottom of the board. Of course, I'd have to remove the board to do that, and that means removing all of these jumpers and cables. So to do live testing, you've got to keep the board in the circuit. So if I do have to pull the board out, though, I think I might add some test points to this just because I can, I guess. Anyway, time to move on here. I was able to connect to the D16 cathode here, and I've still got noise, but I expected it to be amplified, so this stage has got a lower level. I'm wondering if I've got a problem. If this cap went bad here, that would create degeneration, which would lower the gain of this, and that is an electrolytic. I'm almost tempted to pull this board and just replace this cap, and this cap. I'm going to try to measure the base here on Q19. Yeah, I think we got a problem right in here. I removed the cables from the main board here. Caps I'm going to replace are in this area, so by tilting it over I get pretty good access. And I've noticed there's a few solder joints here that don't look that great, so I'm going to replace those caps, and I'm going to redo a few solder joints I don't like, and then I'm going to put it back in and try it and cross my fingers. So that will be next. I replaced all the electrolytics in the squelch section here, and I found two of them were very leaky. These two here. So that seemed to cure the problem. Anyway, here's the squelch. It's working. Test, 1, 2, 3, test. There is what? 1, 2, 3, a little over 5 watts. Test, 1, 2, 3. Test, 1, 2, 3, test. Test, 1, 2, 3, test. Hello, test, 1, 2, 3. Hello, test, hello, 1, 2, 3, test. Test, 1, 2, 1, 2. 1, 2, 3, test, 1, 2, 3. There's the higher power. 1, 2, 3, test. There's the low power. Test, 1, 2, 3, test. Hello. So I had a couple of these caps were leaky, and that's what caused the problem with the squelch. But that is working now. Oops. Test, 1, 2, 3, test. So anyway, I think I got this thing fixed. Ideally, I should replace all these electrolytics, but I like to fix things till they work, and then I'm not going to do a restoration on this whole thing. I just fixed it till it worked, and someday I'll try it and it won't work, and then I'll just fix it again. I'm not going to sell this or give it to anybody because I don't have a lot of confidence in it. It's pretty old, but I do like these old rigs. They're fun to work on, and they're very well built. But it's getting old, and these capacitors are getting pretty old. Here's that section where the squelch is. You can see the new caps in here. So anyway, I'm going to go over the schematic really quick. People seem to like that, and then I will call this video done. Here's a brief description of the Icom here, and I'll show where the problem was on the main board here. Anyway, the signal comes in through the antenna connector. It goes through the low-pass filter. There's a TR section that it's switched between, using pin diodes, switch between transmit and receive. Then the receive is connected in through here. You can see J2 here. It's connected into the RF amplifier here, which is Q3. The output of Q3 is fed through 4 helical resonators here, and they help to filter out a lot of the junk that's coming in from this side here. From the helical resonators, they go into a double balanced mixture here. You can see there's 4 diodes here, and they form the first mixer here. If you look here, there's a signal from the PLL unit that comes up through and is connected into the mixer here. And here the incoming signal is mixed with the first local oscillator to produce the IF, the first IF. The first IF is 16.9 megahertz. Then it goes through a couple of filters here, coupled into Q2. Here that first IF is amplified. Then it's connected to second mixer down here. And in this section here, if you see here, C6 couples the first IF down through this line, and what is it, C5? It's hard to tell here, C5? C3 or C5, I can't see it. Anyway, this capacitor here couples this oscillator in here to the second mixer, and those two signals are mixed, and it produces the second IF of 455 megahertz. Goes through a filter here, IF amplifier chain here, finally through a limiter here, and then it's detected here with a detector. So the problem with this unit was, as far as the receive goes, was the squelch circuitry didn't operate. And the way it works is the signal is picked up here. When there's no incoming signal, there's high level of noise on this line. It's audio from here over to here. Anyway, the noise level is really high here, and that's coupled out through here. I've shown this in blue. I drew it in blue. And it's coupled out through J8 to the squelch control on the front panel. And the squelch control is connected back through the wiper through this J8 through squelch 2. It's coupled into this chain here. Now this is the squelch amplifiers. What happens is the noise here is amplified by these two transistors, then it's detected and it's filtered here, and then the output of that drives Q19. Now this transistor here, when this is turned on, see a positive level that's produced across this cap. This is one of the caps that was bad, by the way. That'll create Q19 to conduct, and that pulls the signal down to ground here. So when a signal comes in, the noise level goes down, and then Q19 opens and lets the signal go into the amplifier here. So after that point, it's audio. It's amplified by Q15 and 16, and the input of Q16 has a low-pass filter here. They've got a couple caps that help filter out some of the junk that's coming in on the audio line. And then the output here from the audio circuitry comes out through this connector to the volume control, comes back in here, feeds IC4, which is an audio amplifier, and then the output comes here. I found a number of caps that were bad here, that were leaky, lost a lot of their capacitance. That's why this circuit didn't work here. They were in the circuitry here, so they're all been replaced. Anyway, that's a brief description of the operation here of the receiver. Transmitter's working good. I found a bad solder joint that was causing the trouble with that, so I'll have to try this on the air. I don't have a tone board on here, so I won't be able to access the repeater with it unless I add a tone board, which I actually have some tone boards. I might do that. Now I did repair another one of these in a older video. It had a bad PA unit, and I fixed that, but this one's got a good PA amplifier in it. I was going to use this as a donor unit, but sometimes you just hate to do that. It very clean unit, looked really nice, so I decided to fix it. So now I got two of these things. Anyway, that'll do it for this video. I hope you enjoyed it, got something out of it, so we'll see you in the next one. Bye for now.